In this lesson, we are going to learn about simplifying algebraic expressions. This is section 1.3 on page 87 of your textbooks, and we're going to work problem numbers 2 through 40 even. The first set of directions are going to cover problem numbers 2 through 6 here, and the direction set says to list the terms of each expression. So I generally tell my students that terms are separated by addition signs. The reason is to help you guys not mix up your signs, okay? So when we look on number 2 here, we've got 7a minus 4b. Well, we don't see any addition signs here, but we do see a subtraction sign. And as we know from the video from section 0.3, when we subtract two terms, we know that our rule is keep, change, opposite. So keep the 7a the same, change the subtraction to addition, and the opposite of 4b is negative 4b. Now we see our addition sign, so you have two terms. You have the term 7a, and you have the term negative 4b. All right, the reason I say they're separated by addition signs is because a lot of people are going to miss that negative there if you don't do that keep, change, opposite rule. Okay, so what you guys are going to do to actually list your answer, when the directions tell you to list terms of an expression, you're going to write your two terms, 7a and negative 4b. Now, if we were to leave it in this form, you could say that I just rewrote the problem. Well, that's not what we're doing. We're listing. So if I were to tell you to list the days of the week, you would say Monday, Tuesday, Wednesday, Thursday, Friday, and then you would put commas or slashes in between. So what we're going to do is to say that we're separating these two. We're going to say that we have 7a and negative 4b. Sorry about the light changes, guys. The light's going a little crazy in here. Let's see. Hopefully that'll make it a little bit easier for you guys to see. I turned the brightness down on the video just a little bit. Okay, so when we look at number 4, there is no addition sign. This is a term. This is a problem where you're only going to have one term because there are no addition or subtraction signs. So your term is just simply 3x squared. And there's no comma needed because there's only that one term. Number 6 truly is going to state whether you understand or not. So we're going to have 3 terms here. We're going to have 2a to the third, negative a squared, and positive a. Don't forget that negative with that a squared. That's where most people lose their credit on this problem. So you would have 2a to the third, negative a squared, and a. Notice we are listing the terms and putting commas in between each of those terms. Okay, now for problem numbers 8 and 10, the directions tell us to identify the like terms in each list. The directions, when you look at your test and on your study guide, the directions are going to tell you to circle the like terms, okay? So a like term is when you have the same variables and you have the same exponents. Now this number in front, like that 9, the 8, the 5, and the 7, those are called coefficients. Coefficients are the numbers in front of your variables. Those aren't going to impact whether or not they're like terms or not. Okay, so you're only looking at the variables and their exponents, and they have to be the exact same. So when we look at this list here, we're going to look and see, well, is there anything that has an m squared in common? And if we look, we have a 5m squared. So those are my like terms, and you can have more than just 2 like terms in a problem. But I'm going to show you one other. I'm writing this in red because this is not included in the problem in your textbook. I'm adding this into it as if it were a problem. Let's say we had just an m squared. Well, that m squared is considered a like term. What normally throws students off is that there isn't a coefficient. But you have to think to yourself, what number is understood to be in front of a variable if it's not written. The understood number is a 1. Now it looks like all the other ones. It has that number in front. It has the m squared. So if this had been a part of the problem, you would have included that m squared as well. So now we look down here and we look for terms that have the same variables with the same expression, or with the same exponents. Well, we know we can't use this because it doesn't have any b's. Everything else has b's. There's nothing else that has just an a squared. Same here. Can't use this one because it's just a and b. It doesn't have any exponents, and everything else does. So when we look here, we've got an a squared b. That doesn't have an a squared b, but that does. So since this now has an a squared b and this has an a squared b, lets me know that that's my like terms that I'm looking for here. Notice how the a is squared here and the b is squared here. That's the difference between those two. And you also notice that that is also a like term. Now don't let the fact that this one is negative and these are positive throw you off. The negative is a part of it being a coefficient. That does not change it. The only thing that will make it not a like term is if they don't have the same variables or they don't have the same exponents. So I'm going to take my red pen out again, and I'm going to add something to this problem as if it were a part of it. And I'm going to say we have just a squared b. So again, you might get confused and say that this isn't a like term, but if you remember there's an understood 1 in front, then you might say, okay, now they're like terms. So that's just showing you that if there's not a number in front, don't freak out, it can still be considered a like term. Now, let's go ahead and look at problem numbers 12 through 32 even. The directions tell us to combine our like terms. So on problem number 12, move this up a little bit, it says we have 6a squared plus 8a squared. So let's say that the a squared represents apples. And let's say you have 6 apples plus 8 apples. Well, then you would tell me that we had 14 apples. So when you combine like terms, your answer will also be a like term. I'll say that one more time. When you combine like term, your answer will also be a like term. So when you notice that these both have a squared, that means your answer is also going to have that a squared. In order to combine terms, they have to be like, meaning they have to have the same variables and they have to have the same exponents. So here we have 7rs plus 13rs. Well, 7 plus 13 is 20. And you're going to still have that rs in your answer. 16, notice, they are both like terms. So you can go ahead and combine them. 4n squared m plus 11n squared m is going to give me 15n squared m. Problem number 18, a little tricky. 7m minus 6m. Okay, well, let's say you've got 7 mushrooms and you eat 6 mushrooms. Well, you now have 1 mushroom, so 1m. You could also write this answer as just simply m because that 1 in front is understood. Either way will work. 9xy minus 13xy. Well, 9 minus 13. You have, let's say, $9. You spend 13. You didn't have enough money to spend, so you're in the hole by $4, but you still have a like term of xy. So if you needed to do the keep change opposite for that one, feel free to do so. 22, another tricky one. 7CD minus 7CD. Well, when you subtract those, that gives you 0. You could write 0 for your answer, or you might see it written as 0CD. Either one I'll accept. Okay, number 24. You have 8r cubed s squared minus 17r cubed s squared. 8 minus 17 is negative 9. And remember, you keep the r cubed s squared. Okay, let's move on to problem number 26. All right, so notice we have 3 terms now, okay? And they all have UV. So that means that they are all like terms. So what we're going to do is we're going to take this one step at a time. 13 UV plus 5 UV is 18 UV. And then you bring down that minus 12 UV. Now we work this part. Remember, order of operations. Do addition and subtraction, left to right, whichever one comes first. So 18 minus 12 is 6. And your answer is still a like term, so it would be 6 UV. Number 28. This one is where we start to get a little tricky. So notice 5m squared minus 3m plus 6m squared. Not everything is like. This negative 3m is not like because it doesn't have that squared. It's missing that. So that means it's not a like term. So I can still add the 5m squared and the 6m squared, which gives you 11m squared, and then you bring down that minus 3m. I will go ahead and let you know that they're normally, your terms are written in what's called descending order. We'll learn more in section 5.3, but in descending order, that means that your terms are going to come where your highest exponent comes first, then your lower exponent. Remember, that's understood to be a 1 there. Okay, so just so you know why I put the 11m squared first, that's why. All right, problem number 30. Number 30, we have 7a minus 4a squared minus 13a plus 9a squared. Something you can do is you can put hearts around like terms. Don't forget to include the sign. And you can put like a squiggly line under the other like terms if that helps. You could use squares, you could use triangles, you could even use different colors, whatever helps you understand and get the correct answer. So I'm going to use my highest exponents first, which are going to be my hearts. I've got negative 4a squared plus 9a squared. It's going to give me a 5a squared. So you owe somebody $4, you give them 9, so that means that they have $5, okay? All right, so now 7a minus 13a is going to give us a negative 6a. Problem 32. I'm going to draw hearts around my squares. Notice how I include that minus sign in there. I'm going to put a squiggly line under my p's. And I'm going to put a little rectangular box under my numbers by themselves. And just so you know, with the terminology, a number that is by itself is considered a constant. So I've got 5p squared minus 7p squared. That's going to give me negative 2p squared. And you can cross these out as you go if it helps you. There's no problem with that. Then you have negative 2p plus 5p gives us 3p. Done with those. And then you have negative 8 plus 6, which is a negative 2. And the last part that we're going to explore in this section are going to be removing parentheses. And they ask us to simplify where possible. So to remove a set of parentheses, we need to understand that there is an understood number that is in front of a set of parentheses if it's not written. Understood number is a 1. Notice how I just drew that 1 there. Excuse me. So since there was already a negative in front, that means this is a -1. And this means we are going to use what's called our distributive property. Your distributive property tells you that you are going to distribute or multiply the number on the outside of the parentheses with each term inside of that set of parentheses. So that means we're going to do -1 times 7x, which is -7x, and then -1 times -4y. Notice that 4y is negative, gives you a +4y. Now, notice that these are not like terms. One has an x and one has a y. So due to them not having like variables, they're not like terms, meaning this is as far as we can go. Okay, so now let's look at problem number 36. On problem 36, they want us to remove these parentheses. Remember, there's an understood 1 in front of that set of parentheses. And you're going to distribute or multiply that -1 times each term inside of those parentheses. So we're going to bring that 7x down. -1 times 4y is -4y. -1 times 3z is negative. None of them are like terms, so that's as far as we can go. Problem number 38. Do the same thing. We're going to distribute that -1. So we bring down that 10m. -1 times 3m is -3m. -1 times -2n is a +2n. Now notice that we can simplify here. There are like terms that we can combine, which are right here, these m's. So 10m minus 3m is 7m, and you bring that plus 2n over. That's what they mean by simplify where possible. And then finally, let's look at problem number 40. We are going to distribute that -1. So I bring that 8d down. -1 times -7c is a +7c. A -1 times -2d is +2d. Now we're going to learn something else that about the order that things go in. We are also going to learn that our terms are going to be put in alphabetical order. Okay, so in the order the alphabet goes in. So notice you have some like terms here. You have those D's that are like, but you also have a C. In the alphabet, the C comes first, then come your D's. So 8D plus 2D is 10D. And it comes after the C because of the alphabetical order. Y'all are going to have a couple of weeks to get used to this terminology, but I'm going to go ahead and introduce it to you now, just so it's not as much of a shock when we get into Unit 4. I hope this video has helped you about simplifying these algebraic expressions. I wish you the best of luck.